Did you know that energy dispersive spectroscopy, or EDS, can detect elements as light as boron and as heavy as uranium? That's an impressive range considering the periodic table consists of over 100 elements. But what exactly is energy dispersive spectroscopy, and how does it work? Imagine a detective meticulously scanning a crime scene for clues. In the realm of material science, EDS is that detective. It's a method used to analyze the elemental composition or chemical characterization of a sample. It's a vital tool in the toolkit of any materials scientist or forensic investigator. At its core, energy dispersive spectroscopy is about energy and dispersion. The process begins by bombarding a sample with a beam of electrons. This high-energy beam excites the atoms within the sample, causing them to emit X-rays. These X-rays are then detected and measured. Each element in the periodic table produces X-rays at unique energy levels when excited. Think of these as the element's unique fingerprint. By measuring the energy of the X-rays emitted by a sample, EDS can identify which elements are present. But it's not just about identifying what's there. Energy dispersive spectroscopy can also give clues about the quantity of each element. The intensity of the X-ray signals is proportional to the amount of each element in the sample. So the stronger the signal, the more of that element is present. Now let's dive a bit deeper. The beauty of EDS lies in its versatility. It can be used in conjunction with scanning electron microscopy, or SEM, to provide spatially resolved elemental information. This means not only can we find out what elements are in the sample, but we can also determine where they are located. So, we've discussed how energy dispersive spectroscopy works and how it's used. But why is it so important? Well, in materials science, knowing the elemental composition of a material can provide insights into its properties, such as strength, electrical conductivity, and resistance to heat or corrosion. It's also widely used in forensic science to analyze trace evidence. To recap, energy dispersive spectroscopy is a technique that uses a beam of electrons to excite atoms in a sample, causing them to emit X-rays. By measuring the energy and intensity of these X-rays, EDS can identify and quantify the elements present in a sample. And when used with scanning electron microscopy, it can also provide spatial information about these elements. In the realm of scientific research, energy dispersive spectroscopy is a powerful detective, uncovering the elemental secrets hidden within materials. From materials science to forensics, its applications are as diverse as the elements it can detect.